Assalamualaikum guys. Today we are going to do another new chapter under structure and bonding, that is electron pair geometry. Previously we have studied about what is meant by the whisper theory, how this whisper theory going to impact on your shape and the geometry. So here I am going to introduce what is meant by geometry. I am Najim Shah. Just let's move on to our content. First of all, we have to know what is meant by electron pair geometry, what we are going to study, how we are going to deal it. That is what I am going to speak in introduction. And next, the comparison of repulsive forces between the bonding and lone pairs of electrons. Actually, when you are speaking about the pairs of electrons, right? So, what is the contribution of the pairs of electrons? We already studied under whisper theory. That is what is meant by the whisper theory. Valency, shell, electron, pair, repulsive theory. This is what we are going to speak here. So when we spoke about that, we told, right, when you said about the pairs of electrons, so they can make the two type of the bond, right? Two type of the shapes, right? So what is mean by how this electron pair geometry is going to make on impact? Yes, one is what they are not participating in the bonding, that we are telling what that is the lone pair, and the electron pairs which is participating in the bond, we are calling that is the bonding electrons. Let's move on, right? And next, what is mean by electron pair geometry, right? From this repulsive photons and this, right, comparison, we are going to step into what is mean by the electron pair geometry. Let's move on to the introduction now. Yes. So what we will speak about in our last presentation. According to the whisper theory, the molecules or ions achieve stability by maintaining a maximum distance between the repulsion units to get the minimum repulsion force between them. So this is what happening in whisper theory. So when we spoke about the whisper theory, we spoke, right? The molecules or ion, right? They need to achieve the stability. For that sake, what they are doing is they are maintaining a maximum distance between the repulsion units to get the minimum repulsion force between them. A lone pair of electrons occupies a greater spatial distribution compared to the bonding electron pair. I said we have talked about the two type of the electron pairs. Yes, one is the lone pair, another one is the bonding pair. When you speak about the lone pairs, right, they are getting the very large spatial volume compared to what the bonding electron pair. So that's say it's considered the repulsion between the two electron pairs of electrons, right? That means lone pair is higher than the repulsion between the two pairs of electrons. Bonding pair of electrons, that is bonding pair of electrons. So what they are telling is the repulsion. What is meant by repulsion? The attraction, the distribution, right? The distance what is maintained in between the electron pairs. So when you speak about them, right? So simply they are telling what they are telling. Yes. The repulsive force always between the lone pair, lone pair, higher than, higher than the bond pair, bond pair. This is what they are telling us. So when you take a molecule, right? Okay, I can show you another example. So lone pair, right? You have the water molecule. So let's redraw the Lewis structure for the water molecule, right? Yes, oxygen, H, H. So here we have two lone pair. The repulsion between the lone pair should be higher than the repulsion between so you will be confused, right? So we'll show like this. Oxygen, right? Hydrogen, okay. So actually what is happening here? Okay? The repulsion between the lone pair should be high. Figure 1. The repulsion between the lone pair bonding pair. So simply you can say theta 1 is always higher than this. So what is about the repulsion between the bonding pair, lone pair? That is you can see. Yes. Yes, so we said the repulsion between the lone pair should be higher than the bonding pair. So when we speak about the yes, the lone pair and the bonding pair, that should be intermediate. That's all. So this is what we are talking in next slide. Right. Let's move on to the next slide. So we talk about this. Yes, this reserves the intermediate repulsive force for interaction between lone pair and bonding pair of electrons. So simply you can say the comparison of repulsive forces between the bonding and lone pairs of electrons. The first always the repulsion between the two bonding electron pairs is less than. So what should be the intermediate? Yes, the repulsion between the bonding pair and the lone pair, right? Okay, and this is than less than the repulsion between yes lone pair. So simply you can say what their meaning is, right? This is the increasing order of what the repulsive forces between the bonding and lone pairs of electrons. So the which has the minimum repulsive force, your bonding pair, and your next one is the bond pair and the electron pair. The final one which has the highest repulsive force, that is lone pair, right? So because of this, the distribution of the repulsive units, because of this distribution of the repulsive, the bonding all lone pair. In the space around the central atom is called the electron charge. How that word is arrived? Why? We spoke here. What is meant by the repulsion force? Because of this repulsive force, the presence of the bonding pair, the lone pair, which finally results in the electron pair geometry. Why the distribution of these repulsive units, the bonding or lone pairs, around the central atom is called electron pair geometry. When starting, when stating the geometry of the particular molecule or ion, it is necessary to report the bonding angles. So the angles are very important. We said the word called the electron pair geometry. So when it speaks about the geometry, right? Speak about the geometry, you definitely have to mention about what the bonding angle. The following table summarizes the different electron pair geometries depending on how the repulsive units are distributed in 3D space. So let's move on to the table. So look at here very carefully. The repulsion unit is given here. The repulsion unit means what? The Vesper unit, right? So the bond angle, and finally, what is the name given for that electron pair geometry? So when is your repulsion is true, what should be the bond angle? 180 degrees. You can see this is very clearly. So why this is as a 180 degree? This is not new for you. You have studied in your O-level too, right? So when it's linear, you have only two. The two means what? This is your central ladder, right? You have the two sides of the bond, right? You might have two bonding pair, so it end up with what? Linear shape 180 degrees. So what is that electron pair geometry? Linear. And the repulsion unit 2, the next one should be what? The repulsion unit or Vesper unit is 3. So what should be your bonding angle? So before Joe, I will show you, right? What should be the bonding angle? This is your metal, central metal, right? And 3 means what? Be able to form such kind of bond, right? Can say a ligand or whatever, and just write it. So in between this bond, you will have 120 degrees Celsius. Like your, yes, what is that? Trigonal, right? So we are telling this is on the plan, the word called trigonal plan, right? So the electron pair geometry calling as the trigonal planar. Let's see. So planar means which is set by what? This dotted line. So that is on the same plan, right? And the angle between the two bonding, that is 120 degrees, right? And this is called as what? The trigonal planar. So let's move on to that. So we have studied the repulsion unit 3. Now we are going to step it. So what should be the bond angle? Again we will go. Yes. So when it speaks about the bond angle, right? Okay. This is your middle, and here you might have the 4 bonding according to your ligand. And this angle we are telling 109, and approximately I said the 109. You can say 10.3. Approximately if you want to mention it, right? So in your level, if you mention like this, that is enough. And what should be this shape is tetrahedron, right? Okay, let's review. Okay, here they mention only the 109. That is enough. and the electron pair geometry is tetrahedron. The next repulsion unit is 5. So what should be the bond angle? That is a very much. Now we are going to step into the little bit complicated shape. So we take the annotation. Yes. The first thing is the three repulsive units are on the same plane with 120 degrees. So I can show you that. So this is what your metal, right? The three repulsive units should be what? Right? The repulsive unit, the three repulsive units should be 1 degree. Right. That should be what? On same plane. So when you say that is what should be trigonal plane, right? And we'll use another color. And the two repulsive unit, right? We are talking about three repulsive unit on the trigonal planar shape, that is 120 degree, and other two repulsive units lie perpendicular to this. So the perpendicular word is very important. That should be. Okay, I will erase that part. Here. Right? So this is what we are calling is trigonal bipyramidal. And simply you can say this is 120 and this is LL, perpendicular for this trigonal planar. That's why we are telling this is as the trigonal pattern. Right. Yes, we see the actual diagram. So simply you can see here what the perpendicular means what? That should be 90 degree for that plan. So can you see the dotted line? So this is what your plan. Your planar means what? Planar. So this is what we are telling is you can see the trigonal planar that is having the 120 degree variation. So other two repulsive unit perpendicular for that plane. So what is happening? That is 90 degree angle. So this is what we are calling as the trigonal bipyramidal. The three repulsive units are on the same plan. So these with 120 degree angle. The other two repulsive units the lie perpendicular this plane. Right? Okay. So let's move on to the final tabulation. That is when you have the repulsion unit 6. So simply that is also seems to be similar. What we had studied under your trigonal bipyramidal. So here also since the same thing is you can see the metal having the four repulsive units are on the same plane. Right, that should be same plane. So that what? 90 degrees. Oh, I don't want to show you. So that should be what? The 90 degree. Each should be 90 degree and here other two repulsive units perpendicular to this plane. So what is happening? That's all. And this is also. And simply you can say what is the shape of the hadron. So you should be very careful about that. When you have this octahedral, the 6 repulsive unit distributed like this, the 4 repulsive unit on the plane, right? You can see, right? Okay, and other 2 repulsive units are perpendicular for this plane. So this is what we are calling as the octahedron. So let's remove create justification. Right, simply you can see what that is on the plane. So what is happening, the distance between the angle between the 2 repulsive units, that is the 90, and other 2 r should be the perpendicular for that plane. So what is happening, that is the 90 degree, right? So we are telling that is as the octahedron. Okay, the 4 repulsive units are in one plane, so with 90-degree angle between them. The other 2 repulsive units lie perpendicular. So this is what we have to understand. Right. So now we have studied the different geometry. So what is telling? When reporting the shape of the molecular ion, it is not mandatory to report the bond angle. Right. We have spoke about what? The geometry. Right? The geometry will simply step into the shape. When you speak about the shape, right, it is not necessary to report what bond angle. However, when stating the geometry of the molecule or ion, it is necessary to mention the bonding angle. So what I am speaking here, one is a geometry, one is a shape. Yes, from the geometry, you are going to speak about the shape. When you speak geometry, you have to mention the angle. But when you go for the shape, it is not necessary to mention the angle. So why? How this geometry differentiates from the shape? This is what we are going to study later part by one. What is the different shape under the trigonal planar? Linear, tetrahedral, yes. What is next one? Trigonal bipyramidal. And finally, octahedral. So we are going to study the different shapes and these geometry one by one. So you will get the different percentage. So this is what they are showing here. So therefore, the electron pair geometry, shape, and the geometry of the molecules are considered as a 3 independent parameters. So what are they? The geometry of molecules carries a shape and the angle. The geometry of molecule associated with bond angle in Lewis structure representing the shape. The shape of the molecule represents the Lewis structure in order to illustrate the shape without the bond angle. So electron pair geometry represents the geometry of repulse. So this is what they are telling. So again, I'll just go through what they are telling us. The geometry of a molecule carries a shape and the angle. We said, right? Yeah, when you speak about the linear, you have 180 degree. That is what, if you have the 2 repulsion, we are telling that it has a linear. When you go for the 3 repulsion, that is what carries the 120 degree, that is trigonal planar. So planar. So when you go for the tetrahedral, that is having the 109 degree, right? So that has the 4 repulsion. Likewise, your star pyramidal, bipyramidal, trigonal bipyramidal, and the octahedral. It's related. The geometry of molecules, that is also very important, associated with your Lewis structure, which is representing the shape. So definitely, if you want to understand, if you want to find the geometry and the shape, what is the step? The first step is you have to draw the Lewis structure. From the Lewis structure, you have to define the Whisper repulsion theory, right? After that, we are going to speak about the geometry. Finally, you will lead to the shape. So this is the direction. So again, I'm just mentioning you all. The first step is you're able to draw the Lewis structure. From the Lewis structure, you should able to define your Whisper units or repulsion units. From the repulsion units, you should able to say what is the geometry. And finally, from the geometry, we are going to speak about the shape. When you mention the geometry, the angle is very important. Right. This is the order of finding the shape. Okay, you will be clear next presentation. The shape of the molecule represents the Lewis structure in order to illustrate the shape without the bond angle. I said when you speak about the geometry, we need the angle, but shape we are not going to speak about the bond angle. The electron pair geometry represents, yes, the geometry of the repulsion. Simply, that's what they say. When you speak about the electron pair geometry, it simply represents what? Your repulsive units. And let's see electron pair geometry. Okay, we will have the annotation. So the number of region, right? When you have the two regions of high electron density bonds and unshared pairs. So when you speak the two regions, simply you can say the Western system. The spatial arrangement, yes, what is that? 180 degree, we are telling what is that electron pair geometry linear. The angle is 180. So example is the beryllium hydride. So BH, that should be linear shape. When you go for the three region, the high electron is the bond and the unshared electron. Here we spoke about the bond for unshared electron. Here also we are going to speak about why they are mentioning like that. This is what we are going to study the next following presentation one by one. Here again I am just recalling. You can see the diagonal planar, right? So why it's having the 120 degree. So this is what the shape, and the boron hydride or say trihydride BH3, you are end up with what trigonal plane 120 degree. And go for the four region, right? So that is also bonds and the unshared electrons pair. So unshared electron means what? The lone pair. Right? Here I said, okay, the approximately we sell the D3, you can say the 5. Even though you no need to say that is 109 degree is enough. Right? You can see the shape, right? That is what is the shape is tetrahedron. And your methane CH4. And the 5 region we are telling is trigonal bipyramidal. So that is what is that we already said the 3 repulsion units should be on the plane and the 2 is perpendicular. So this is what the phosphorus pentafluoride PF5 we are telling that is. You can see the 120 degree of the angles of the 120 degree and 90 and attach it may be equatorial in the plane of the triangle or axial above the below and plane. So next one, the final one is having the 6th region. The 6th region having what? Yes, the unshared bonds electron. I said the 4 repulsive unit on the planar. So that is the 90 degree first, 90 degree. And the other 2 repulsive unit perpendicular for that plane, that is also 90 degree. So we are ultimately that is we are telling as SF6, sulfur hexafluoride. So this is to this that is also octahedral. We said yes, altogether having the 94. This is what it's a summarizing of what your electron pair geometry. So that's all, guys. We have studied about the electron pair geometry. What are the different types of the geometry? Inshallah, next presentation we are going to speak about what the different geometry having the different shapes, right? According to that, we are going to study one by one. Until that, see you. Bye bye. Assalamu alaikum warahmatullahi wabarakatuh. Take care, guys.